This is lesson 5.6, Graphing Inequalities in Two Variables. Your objectives are to graph linear inequalities on the coordinate plane and solve inequalities by graphing. The solution set of an inequality that involves two variables is graphed by graphing the related linear equation that forms a boundary of a half plane. The graph of the ordered pairs that make up the solution set of the inequality fill a region of the coordinate plane on one side of the half plane. So what this basically means is we're going to graph a line on the coordinate plane, and then a region either above or below the line will be shaded. If you copy down these charts, when you have the inequality solved for y, just like in y equals mx plus b, if your sign is less than or greater than, it'll be a dashed line. If it's less than or equal to or greater than or equal to, it'll be a solid line because the line is included when it's equal, but it's not when it's just less than or greater than. Once it's solved, if y is less than, the shading goes below. And if the y is greater than, it's shaded above. Graph each inequality. Number 1, y is less than 4. The first thing to do is solve for y. Since this is already solved for y, let's go ahead and draw the boundary line. The boundary line will be where y equals 4 would occur. And when you have y equals a number, that's just a horizontal line through that number. Since this is y is less than 4, the line is not included because it's not equal to. So we will have a dashed line. It's a horizontal line through 4. Now, since y is less than that, the lesser y values occur below. So we'll shade in below. Solve for y, determine whether it's a solid or dashed line, and determine where you're going to shade. Since it was less than, we shade below. Number 2, x is greater than or equal to 1. Well, I can't solve for y because there is no y. So instead, I'll solve for x. And this one's already solved for x. This is like the line x equals 1. And when you have x equals a number, it's a vertical line through that number. So this will be a vertical line through 1. Since it is equal to the 1, it'll be a solid line. Now where do we shade? We can't shade above or below a vertical line. So let's think of how the x would work. X deals with numbers to the left and to the right. So we can make an additional chart for the x values. When x is less than or equal to, we'll shade to the left because the lesser x values are to the left. When x is greater than or equal to, we'll shade to the right because the greater x values are to the right. Since in this question x is greater than or equal to 1, we'll shade to the right. Draw the line, determine whether it's solid or dashed, and determine where to shade. When it's a vertical line, you're going to shade either to the left or to the right. Greater than is to the right, less than is to the left. Number 3. 3x is less than or equal to y. Let's solve this for y. Since it's already solved for y sort of, except the y is on the right instead of the left, let's just turn everything around and put the y on the left. Since the mouth is open to the y, the mouth is still open to the y, so that flips around to a greater than or equal to, and that'll be a 3x. Now let's think of this being in slope-intercept form. Y equals mx plus b. Well, we don't have plus anything, and since we don't have a plus anything, That's really a plus 0. Since it's greater than or equal to, we're going to have a solid line. So let's find where that line goes. Start with the y-intercept, which is 0, put a point, and then use the slope. The slope is 3, and you can put 3 over 1 so you can rise over run. When we rise 3, run 1, that'll go up 3, right 1 to a point right there, and it is a solid line. Since y is greater than, it will be shaded above. Solve it for y. Draw the line. You can start with your y-intercept and then use the slope to rise over run to the next point. Is it solid or dashed? And where do you shade? Since it was greater than or equal to, the line was solid, and since it's greater, we shade above. Number 6. 2x minus 3y is less than or equal to 6. Well, I need to have this solved for y first. To solve for y, we move what's added or subtracted, which is the 2x. It's a positive 2x, so we'll subtract it from each side to move it. The 2x's cancel on the left, and that leaves a negative 3y. Instead of writing 6 minus 2x, write negative 2x plus 6, because for y equals mx plus b, we want the x's first. Then divide both sides by negative 3. The negative 3's cancel, leaving a y. Since we divided by a negative, we flip that sign around, so now it's greater than or equal to. Negative 2x divided by negative 3 is a positive 2/3 x. 6 divided by negative 3 is negative 2. And now we can graph the line. Start at the y-intercept, which is negative 2. Then use the slope. We'll rise 2 and run 3. That'll go up 2, right 3 to a point right there. Since it's equal to, it's a solid line. And since y is greater, it's shaded above. Solve for y. Graph the line. Make sure it's solid or dashed correctly, and then shade properly. Number 7. Y is less than negative half x minus 3. Well, that's already solved for y, so let's go ahead and graph it. Start at the y-intercept, which is negative 3. Then the slope is negative half. To rise over run, we rise negative 1, run 2. So that will go down 1, right 2, to a point right there. It's not equal to, so this is a dashed line. And y is less than, and the lesser y values are below, so this is shaded below. Number 8. 4x minus 3y is less than 6. First solve for y. That 4x needs to move. It will add or subtract, and since it's a positive 4x, we'll subtract it from both sides. 4x minus 4x is 0, so 0 minus 3y is negative 3y. Instead of saying 6 minus 4x, we will say negative 4x plus 6, because we want the x's first, so it can be in slope-intercept form. Then divide both sides by negative 3. The negative 3's cancel on the left and leave a y. Since we divided both sides by a negative, we flip that sign around. Negative 4x divided by negative 3 is a positive 4/3 x. 6 divided by negative 3 is negative 2. And now let's graph. Start at the y-intercept, which is -2. From there, use the slope to rise over run. The slope is 4/3, so we'll rise 4, run 3. That'll go up 4, right 3 to a point right there. Y is not equal to this, so it's a dashed line. And since y is greater, it's shaded above. The greater y values are above. Remember, equal gets a solid line. If it's not equal, it gets a dashed line. When y is greater, it shades above, and when y is less, it shades below. You can use a coordinate plane to solve inequalities with one variable. To do this, follow these steps. Get everything on one side so that everything will be on one side and a 0 will be on the other side. Step 2, replace that 0 with a y. And then we'll graph it and shade it, just like we did before. The solution will be the shaded part of the x-axis. So we'll follow those steps to solve these inequalities. Use a graph to solve each inequality. Number 1, x plus 7 is less than or equal to 5. Well, you might say, why do we need to graph this? Because wouldn't you just subtract 7 from each side and get x is less than or equal to -2? And the answer is, that is what you do, but this is another method to solve it. So we're still going to get x is less than or equal to -2. Let's use the new method. Get everything on one side. We can move everything to the left. So to move the 5, we'll just subtract it from each side. Step 2 is replace the 0 with a y. Now we graph. To graph though, let's get the y on the left, so let's flip this whole inequality around. Make sure you flip the less than to a greater than. Now graph. The y-intercept is 2. The slope is 1, which is 1 over 1. We'll rise 1, run 1. Since it's equal, it's a solid line. And since it's greater, it's shaded above. Now, the solution is the shaded part of the x-axis. At the borderline, that's going to start right there at -2. It's a solid circle because the line is a solid line, so we include -2. And then everything to the left of that. So that's everything less than or equal to -2. Now, this is just like if we had solved it the regular way. If we had just subtracted 7 from each side, we still would have gotten x is less than or equal to -2. So we get the same answer. We're just finding it a different way. We're finding it by turning it into a two-dimensional half plane. And whatever the shaded portion of the x-axis is, that's our solution. Number 3. -x plus 1 is less than -3. Well, start by getting everything on one side, so let's move everything to the left. We can subtract 3 from each side. 1 minus 3 is -2. Next, replace 0 with a y. Now let's graph it. Let's get the y on the left so we can be in slope-intercept form. Make sure you flip the less than to a greater than. The mouth was open to the y. It should still be open to the y. Now graph. The y-intercept is -2. The slope is -1 over 1. So we rise -1, run 1. That'll be down 1, right 1 to there. Since it's not equal, the line is dashed. And since y is greater, we shade above. Now the solution is the shaded part of the x-axis. It starts right there. But since we had a dashed line, that's going to be an open circle because that number is not included in the solution. And to the right is what's shaded in. So we start at -2 and go to the right. These are the numbers that are greater than -2. It's not equal because it's not included. So x is greater than -2. The open circle to the right is greater than. Number 5. 3x minus 20 is less than -17. Let's get everything on one side so we can move the 17 to the left. It's a -17, so we'll add it to both sides. -20 plus 17 is -3. -17 plus 17 is 0. Next, replace the 0 with a y. And now we'll graph it. Let's turn that around to get the y on the left. Turn the less than into a greater than. If the mouth is open to the y, the mouth is still open to the y. To graph, start with the y-intercept at -3. And then the slope is 3 over 1. So we'll rise 3, run 1, up 3, 1 to the right, put you there. It's not equal, so it's a dashed line. And it's greater, so it's shaded above. The solution is the shaded part of the x-axis. It starts right there at 1. It's an open circle because that's a dashed line. The 1 is not included. And it's everything to the left. So it's the numbers less than 1. All x such that x is less than 1. When it's shaded to the left, it's less than. When it's shaded to the right, it's greater than. Number 6. -2x plus 11 is greater than or equal to 15. First, get everything on the left side, so we'll subtract 15 from each side. Then replace 0 with a y. Now graph. Turn that around so the y is on the left. The mouth was open to -2x minus 4. The mouth should still be open to -2x minus 4. Graph the y-intercept at -4. And the slope is -2, which you can put over 1. That'll go down to right 1, which is right there. Extend the graph if you need to. Since it is equal, that's a solid line. And since y is less than that, it's shaded below. The shaded part of the x-axis starts right there. It's a closed circle because that's a solid line. That number is included. That's -2 and everything to the left of it. So all x such that x is less than or equal to -2. So when you're graphing, make sure you solve for y. If y is less than or greater than, it's a dashed line. If it's got the equal part, it's a solid line. If y is greater, it's shaded above, and if y is less, it's shaded below. When you have the questions like this, get everything on one side, replace 0 with a y and graph, and the solution is the shaded part of the x-axis.